Hello students, welcome to this class. In this class, we're going to cover wastewater treatment. Wastewater treatment is the process of removing contaminants from water that has been used in homes, industries, and factories. This is a mechanism of transforming wastewater into clean water that can be safely returned to the environment. This is the way of making water safe for reuse or discharge into the environment. The treatment process typically includes physical, chemical, and biological methods of to address various pollutants. So the aim of wastewater treatment is the removal of undesirable substances and hazardous microorganisms. Further purification procedures are required before wastewater can be used as drinking water. So, wastewater treatment greatly reduces the incidence of waterborne disease. There is here other forms of wastewater. These other forms of wastewater is sewage. This sewage is a term used to describe liquid wastes that contain fecal matter or water that gets contaminated by human and animal feces. The effectiveness of the treatment process is judged chiefly by the reduction of wastewater's biochemical oxygen demand or BOD. This BOD is a measure of the amount of oxygen needed by microorganisms to oxidize its organic content. A high BOD leads to the removal of oxygen from water. This BOD is act as certain indicator of pollution, or it is a critical parameter used to gauge water quality, especially for assessing pollution levels in a natural water bodies and wastewater. So BOD represents the quantity of dissolved oxygen consumed by bacteria and other microorganisms as they decompose organic substances in a water sample over a specified period of time. A high BOD indicates a significant organic pollution, often caused by sewage, industrial discharge, or agricultural runoff. A low BOD suggests that a cleaner water with low level of organic matter. That means the water in this instance is less polluted. Wastewater treatment usually occurs in stages. The first stage here is primary treatment. This stage allows solids to settle and lighter materials like oil and grease to float. So this stage involves removal of floating and sedimented objects from the wastewater. That means this stage is purely physical. In this case, this primary treatment removes up to one-third of BOD value. The second stage is secondary treatment. This is a biological process that breaks down organic matter in wastewater. So this involves completely microorganisms for microbial oxidation. This leads to further reduction of BOD. So secondary treatment may take one of two forms, both of which are aerobic. That means traditional trickling filter method and activated sludge methods. So in trickling or percolating filter method, wastewater is passed slowly over beds of stones or pieces of molded plastic. That means sewage is screened to remove large pieces of debris. It stands in a large settlement tank to allow suspended matter to settle out. The wastewater is then allowed to trickle through the bed of stones, each of which is covered in a layer of microorganisms that develop a biofilm comprising bacteria, protozoa, fungi, and algae. As the sewage trickles through the filter bed, the microorganisms digest the organic matter and absorb the products. By the time the liquid reaches the bottom of the filter bed, the polluting organic matter has all been removed. That means the resulting treated water has the BOD level reduced by some 80 to 85%. Then the treated sewage can be discharged into the river. The second part of secondary treatment is activated sludge process. This achieves higher degree of BOD reduction. In this case, the sewage or wastewater is screened and allowed to stand in settlement tanks. It is then pumped into treatment tanks where activated sludge, which is rich in microorganisms, is added. Then oxygen is blown through the mixture. In the oxygenated mixture, the microorganisms from the added activated sludge oxidize polluting organic matter. That means wastewater is aerated in tanks that have been seeded with a mixed microbial sludge. The main component is the bacterium Zooglea, which secretes slime and forming aggregates called flocks, around which other microorganisms attach on. After a few hours residence in the tank, the sludge is allowed to settle out and the treated water passes out of the system. But before being discharged to watercourse or rivers, it must be treated with chlorine to remove any pathogen. But here there is one principal operating problem, what we call bulking. Bulking refers to a problem in the activated sludge process where sludge does not settle properly in the settling tanks or clarifiers. This results in poor solid liquid separation, causing cloudy effluent and difficulty in removing sludge. Bulking is typically caused by the excessive growth of certain types of filamentous bacteria called Spherotilus natans. As we can see from the diagram, at primary treatment, physical materials like plastics, rugs, sticks, sand, gravel, oils, and greases should be removed. In secondary treatment, microorganisms decompose organic matter in wastewater through trickling filter or activated sludge methods. Then the sludge and water should be separated and treated differently. Sludge or solid waste gets concentrated and exposed to anaerobic digestion, which results in biogas or methane and carbon dioxide. The sludge then gets dewatered and the dewatered sludge disposed of the environment and used as soil conditioning. The water or effluent should be disinfected or treated by chlorine, ozone, and ultraviolet to eliminate pathogens. Here, nitrogen and phosphorus should be also removed to prevent eutrophication or overgrowth of algae. Finally, the water then discharged into rivers, lakes, oceans, or reused for irrigation, industrial processes, or drinking.